Hello everyone, welcome back to my channel. I know this video is coming after a long time, approx 1 year, but if you have not watched my earlier video on Universal Gate, I will definitely suggest you to watch that video first or watch this playlist entirely so that you can understand what is going on. And I want to rest you assured that I will be putting video daily from now onwards, and you can motivate me by subscribing to this channel and like or dislike whatever you can do in this video. So moving forward, let's start with the binary addition and half adder. First, we will understand about binary addition. So what is binary addition? Basically, binary addition is just addition of two bit binary number, addition of binary number. So what is happening here is we are starting. Suppose what is binary number? First, if you have not watched my earlier video, you might be not understanding it. But if you have watched it, I have told you about binary number. So binary number is the number having 0 and 1. Suppose you have a number 111. I think it is 7, okay, and 110. This is 6. So I have already told you how can we know what is this number representing, how we are knowing it. So here, if this is the binary number, first thing we have to note that which is the most significant bit and which is the most I think least significant and most significant bit. Okay, so this is the least significant bit and this is the most significant bit. Okay, so we have to move. Our addition will be moving in the direction from this. So what we can say from rightmost direction to the leftmost direction we will be moving. So suppose this is the case. Suppose let me choose another color and suppose this is the number. I am randomly putting a number, 4-digit number, or you can take one digit also. That's all fine. And this is another number. Okay. So how we will perform a binary addition operation? Okay. So here we are adding 1 and 1. 1 plus 1, it will be becoming in normal mathematics what it will become 2. Okay, but we know that we can only represent any bit by 0 or 1, either 0 or 1. So 2 is not the option. So what will happen? 1 plus 1 will become 0 and 1 will be carry forwarding. Okay, now here in this case 1 plus 1, again 1 plus 1 will become 2, but since we can't represent 2, what it will become? It will again become 0 and 1 will be carrying forward. Now 1 plus 1, again it will become 0 and here 1 will be carrying forward. But now here you see we have 3 1, right? So in this case what will happen? This will become 3, right? But since we don't have any digit to represent, right? So what we will do, we will subtract 3 minus 2. What 3 minus 2 will become? 1. So here it will come 1 and 1 will be carrying forward. So here it become 1. Okay, so what will be our answer? Final answer will be 1 1 0 0 0. So you might be now knowing that what is happening here. Here 1 plus 1 is becoming 2, and we are subtracting 2 minus 2 is equal to 0 and carrying forward as 1. Now, since you have already learned about the binary addition, now we can more dive into what is half adder. So basically, a half adder is a digital circuit. Okay, it is used in various computer applications and various digital electronics. You might have seen the TikTok watch and all those things where we can use half adder. So basically, the primary function of the half adder is to add two single binary digit. Here I am talking about two single binary digit. And what it produced the sum and the carry flag. These are two flag it is producing. So half adder is basically the building blocks for more complex digital circuit, and various arithmetic operation can be performed using the half adder. So I will write here what are the components of half adder. So components of half adder. So basically, as I told you, it work on single bit. So to perform operation, we will be having two input of a single bit. Input of a single bit 1, input of a single bit second B. Let's call them. The first component will be input. How many input we are having? Two input. Input A, input B. Mind it, they are all single bit. It can either be 0 or it can either be 1. Now, the second will be the sum flag. So, the sum flag, what it represent the result of the addition of this input A bit and input B. Basically, it calculate using the XOR, or you can say exclusive OR operation. The XOR get return 1 if the input are different. Suppose one input is 0 and the other is 1, then in that case it will return 1. And if 0, if both are same. I have already covered this in my gate video. If you have not checked out, you can watch it, as I will not be covering it in this video, as it will be more of repetitive work. So first is input A and B, then second is sum, and the third component is the carry flag, basically carry output. So the carry output indicate whether they carry out, means whether the carry operation is done or not. So like we saw earlier, here we see that 1 plus 1 was adding up, and here one carries forwarding above, right? So it will check whether this carry is there or not. So basically, carry operation is using AND gate. When I will be making circuit, I will be making you more understanding in detail. So just now I told you that sum will be using XOR, okay, exclusive OR gate, and carry will be using what? AND gate. So can we make a circuit out of it? Definitely we can make it. So let's start. we have two input. Got it? Input A, input B. Now we are performing an operation here. No, wait. This will be our XOR gate. Okay. What XOR gate will be returning? XOR gate will be returning us sum. Now I will make it in another color, and we are taking input from A and input from B. What will the carry flag carry will use? AND gate. So this is sum, this is carry, and these are two input. So combine this will make our half adder. So now since we have our circuit, can we make a truth table out of it? Means I have told you how to make a truth table, but let's see how we can make a truth table out of this circuit. So we have how many input right now? We have two input. According to this figure, we have input as A and input as B. How many output we are having? We are having output as sum and output as carry. Okay, so what I told, let's first calculate, since we are having A and B, let's write all the possible combination. So I will write all the possible combination first. So 0 0 0 1 1 0 and 1 1. These are all possible combination. As I told you that input will having only one bit, so we are taking 0 0 0 1 1 0 and 1 1. So now let's look at the sum. And what sum is utilizing? Sum is utilizing XOR, exclusive OR gate. What I have told you about exclusive OR gate, that if both the bit are same, then it will be 0. If any one bit is flipped or different, then it will be 1. So in this case 0 0, what it will become? 0. 0 1, it will become 1. 1 0, it will become 0, and here 1 1, what it will become? 0. Now let's look at carry. What carry is utilizing? It is utilizing AND gate. What is the condition of AND gate? If both of them are 1, then only it will be 1, else it will be 0. So if you can check the case 0 0, it will be 0, 0 1, it will be 0, 1 0, it will be 0, and finally 1 1 will become 1. So here is our output. Can we cross verify it? We already know that 0 plus 0 is 0, right? And 0 plus 1 is 1. Okay, 1 plus 0, again it became 1. And here the case 1 plus 1. What is 1 plus 1 becoming? 1 plus 1 is becoming 2, but since we can't write 2 in the binary case, we will subtract it by 2. So our sum will become 0, and what will be carrying forward? We will be carrying forward 1. So you can see the same thing here. The sum has become 0, but we are getting a carry here. Same case I have mentioned above, that if 1 plus 1, this condition 1 plus 1, it is becoming 0 and we are having one carry forward. So before jumping into the code, I will tell you about where it is been utilizing. So first place, as all you know, let me write it. Application of half adder. Application of half adder. So as I mentioned, binary addition. Already we are doing it for a long time right now, so you might be familiar with the binary addition and basically binary addition, but it is only utilized for single bit. We are not using for double bit or triple bit or multiple bit. So basically, since we are working on single bit, so we can say that it is a building block. Means it is just a building block of everything what is going on in circuit, in CPUs, in every arithmetic operations, whichever place it is going on. We also used it in digital counter. Digital counter. So digital counter are used in various applications such as frequency divider, timers, and events counters. You might have heard about counters and all. So half adder can be used as increment and decrement thing. Since uh, counter, you know about counter, so counter, what counter do, it increment value 1 or decrement to value -1, like so. Since we are playing with only single bit, so we can use it as a digital counter. We can also use it in the multiplex and demultiplexer. I will be giving you in more detail when I will be teaching you more of how we can use it in multiplex and how we are using it in demultiplex. But as per now, I will not cover it more. But for the sake of visibility, I will write it here. Plexers. I hope spelling is correct. Or you can Google it, yeah. It is easier. Demultiplexer. Okay. In short form, you might have heard about MUX and DMUX. Yep. So these are not just the three applications, there are multiple applications. It is also used in address decoder or parallel to serial conversion or error detection using the partial bit generation, and also in logic gate building and various other tools development. So now let's move toward the coding portion. How we can code the binary addition and how we can code half adder. I will teach you how can we make gates in Python. So let's move to the coding portal. So this is a online compiler interface. It is basically for Python. I would be sharing this link with you so that you can also practice. So here is run command. Let's check whether our code is running and we are getting any output in the cell. So yeah, we are getting output as hello world. So if you are not in the coding, means not familiar with coding language, so I would recommend you, there are many courses already available in Python. You can go and check it out. I can suggest of some in the link below. means in video description I will suggest you. But if you want me to make any video, then I will make it later after finishing all this quantum stuff and everything. So it will take time, so better you go and see whatever the video is available existing now. So for now I will delete all the code, all the written material which is there. So as talked while teaching, so we will be having three component in half adder. The first component will be, let me comment it out like that. First component is inputs. So there are two input A and input B. Okay. Our second component will be sum flag basically. So sum flag is basically how we are making the sum flag. We are utilizing XOR, exclusive OR gate. I will let you know how we make XOR gate in Python. So our third component is carry flag, and which is our AND gate. I have already made a circuit diagram, so you can check it out how we are doing this. Like, so now we have to follow this route. Means there will be two input and one XOR gate and one NOT gate. So in Python, basically XOR gate is represented by this. In some coding language, it can be power sign or something like that, but in Python, XOR is done by this. So suppose let's check out what is the XOR logic. If both are same, then it should be 0, right? It is coming as 0. If any one of them got changed, then it will be 1. And if both are same, then again 0. So we will be utilizing this same thing. So and for AND gate, for AND we will be utilizing this thing AND. Basically this is just a simple grammar, means in English also we use same as AND, right? So we will be using this. You can also check it if it is working good. So condition of AND is, if both are same, means both are 1, then only, not same, both are 1, then only you will get 1. If any one of them become 0, it will be 0. Check. It is 0. Yep. So we got to know how we can perform XOR operation and how we can perform AND operation. So now let's make a function. In Python we use def for a function, and let's name it half adder. By name itself it is a half adder. It will be consisting of input A and input B, as already told you. Now what will be the sum flag? Basically we use hash to comment out, means this whatever is written in hash does not run in the program. So first thing we are calculating is calculating the sum flag. Okay, so we know that our sum flag, or let me write properly, sum flag is equal to input of A, and performing this operation input of B. We got our sum flag. There is no need of putting like this is simple Python. So our second thing we have to calculate is calculate carry flag. As told, carry flag will be utilizing AND. So input of A and input of B. Got that? Now we have already made a function. It should return something, right? So it will be returning our sum flag as well as our carry flag. So now this is our function created. Now what we need? We need input. Input of A is equal to, suppose our input is 1. Our second input is input of B. We want to check whether we are getting something in carry flag or not. So for now let's take it as 1. We can change it. It's your function, yeah. You can do it anything. So now since our function is returning two values, so you can write like this: carry flag is equal to, call the function half adder, oh sorry, plus this half adder, and pass these two variable, input A and input B. Input A comma input B. Okay, so this is the case. And now since all our this function will be running, and our output sum flag will be storing to this sum flag, and this carry will be storing to this. So now we have to print some value because we want to see something running in the cell, something to be visible in the cell, right? So we can print our sum, right? So print, we can print sum, and there are several way to print, but I am choosing a simple way. So we can see sum flag like this. Okay, and second you can see as carry, and our carry flag will be carry flag. There are several way to print, decorating and everything you can do, but I am choosing a simple way. So you can, let's run our code. Okay, so here we are getting as sum as 0 and carry as 1. Remember, we got the same thing when we were making our truth table. So suppose if I change our input to 0, matlab input, first input to 0. So our sum flag will be 1, our carry will become 0. Suppose both are 0. So our sum will be 0, our carry will be 0. Suppose our A is, input A is 1 and input B is 0. So in that case our sum will be 1 and carry will be 0. So this is a simple code which I have written. You can practice it. It's just a simple thing, yeah, nothing much complicated. If you want to make a code for binary addition also, so I will be making it further when we learn, when we will go into complex coding. For that we will be utilizing loop and all. So let me know if you want to cover that topic also here, means more of coding thing or more of theoretical thing. So comment down, I will making further video accordingly, it will be better. Yeah, so with this I think I should end the video, and I think it is way longer video. I don't make this much longer video oftenly, but let's meet in the next video where we will be further discussing about the full adder, and maybe we will write the code on full adder and application of full adder and various other things moving further. So if you are new to channel, you can subscribe. If you like this video, you can like. If you dislike this video, don't means don't forget to put that thumbs down button. Although I know that it does not show number, but I may get response and it will make me improve my video. So don't forget to put the thumbs down button or comment down everything. Okay. So with this, I will end the video. Thank you. Bye.